Hello, this is Miss Moore, and today during chemistry we're going to discuss empirical and molecular formulas. Today's essential question: how are empirical and molecular formulas determined from percent composition? Make sure you answer the essential question in the summary. Also for today's lecture, you should have handy both your periodic table and your calculators. All right, empirical formula. So empirical formula is the basic ratio of the elements contained in a compound. Okay, it gives the lowest whole number ratio of the atoms and the elements in a compound. And the empirical formula may or may not be the same as the molecular formula. Percent composition is used to calculate the empirical formula. All right, so now, how do we do this? Calculating empirical formulas. The first thing you want to do is list the elements and their known percentages. All right, so let's do a practice problem as we're learning this. So in this particular problem, we'll have 25.9% nitrogen and 74.1% oxygen. So the first thing we're supposed to do is list the elements and their known percentages. What I would do if I were you during these problems is fill out a data table. There's kind of a lot of steps, and I think a data table kind of helps. So the first column in our data table will be the name of the atom or element. And next we'll have our percent. So we'll have nitrogen with a 25.9%. And we'll have oxygen with a 74.1%. Okay, so step one, pretty easy. Okay, the second step really goes along with the first step. It says to write the percentages as grams. Because a percentage means part per 100, we can assume that we have 100 grams of the compound. And instead of calling this, for example, 25.9% or 74.1%, we'll call it 25.9 grams or 74.1 grams. So that part should be pretty easy. Okay, the next step we need to do is to convert 2 moles of each atom using 1 mole equals molar mass. So basically, if you look at nitrogen, what we're saying is that we want to have 25.9 grams nitrogen equals X mole. You guys remember this? Then we set up the grid. And then we need to come up with the equality 1 mole equals molar mass of nitrogen. So what I would put in the second column is molar mass. Okay. And so molar mass for nitrogen, we get off the periodic table, is 14.01 in grams, and oxygen is 16.00. Okay, so that makes this whole process a lot quicker. So for nitrogen, 14.01 grams goes on the bottom, 1 mole on the top. Cross out, stick it in your calculator, and come up with 1.85 grams of nitrogen, no, not grams, sorry, mole of nitrogen, and that's with 3 sig figs. So we'll make the third column the number of moles. Okay, so for nitrogen we have 1.85, and we do the whole process again with oxygen. We're going to have 74.1 grams oxygen. Molar mass of oxygen is 16.00 grams. That's not going to fit. Grams oxygen. 1 mole oxygen. Multiply and divide, and that gives us 4.63, 3 sig figs, mole of oxygen. So we'll put that one here, 4.63. So far, so good? next step, divide the molar amount of each element by the smallest amount to determine the simplest ratio. So if we look at our 2 moles, we have 1.85 and 4.63. 1.85 is the smallest, so we're going to divide both moles by 1.85, and that's going to give us our ratio. Okay, so 1.85 divided by 1.85 is 1. So then we need to do 4.63 divided by 1.85, and that gives us 2.50. Okay, easy enough? All right, last step. The simplest ratio of moles will be the subscripts for each atom. However, if the simplest ratio is not a whole number, multiply the ratios by a number that will result in all numbers being a whole number. So if we look at our ratios, we have 1, which is a whole number, and 2.5, which is not. Okay, and we can't have 2.5 of oxygens. So I'm going to try to multiply that by 2. And that gives us 5.00. And if we have, that means we have to multiply this one by 2 as well. 2. Okay, and believe it or not, that's it. Now we have our empirical formula. We have N2 from this number here and O5. So all of that work to come up with N2O5. Okay, let's try a practice problem. If you think you can do it, hit pause and try to do this by yourself. If you're not sure, do this one with me, and we're going to do one more, and you can try that one by yourself. All right, so we're going to make our little data table. We'll start by listing our atoms and their percent, which we're actually going to call grams. So this time we have manganese, which is 63% or grams, and oxygen, which is 37. Okay. Next step is to list the molar masses for manganese and oxygen. And let's see, manganese is molar mass. So manganese is 54.94 grams, and oxygen is 16.00. And now to determine the number of moles. For manganese, it'll be 50, whoops, nope, that's not right. When we make our grid, we start with what we know, which is 63 grams. And that will be divided by 54.94 grams and 1 mole. And that gives us 1.147. All right, if we do this again for oxygen, we're going to have 37 grams of oxygen. 16 grams of oxygen for the molar mass over 1 mole. And we put that in the calculator, we come up with 2.3 moles. All right, let's get rid of this stuff. So next step is our ratio. So remember, we look for the smallest mole ratio, which I see as being this one. So we're going to divide both moles by the smallest mole, which is 1.147. So we have, and actually with sig figs, this should not be 1.147, should it? It should be 1.1. Okay, so 1.1 divided by 1.1 is 1. And then we need to do 2.3 divided by 1.1. And that gives us 2.09. okay, which is basically 2. Okay, so this time our mole ratio is good. There's going to be a little bit of decision making here. If your mole ratio is really close to a whole number, for example, if you look at the first 2 digits and if you could round up or down pretty quickly to become with a whole number. So for example, 09, really, that's not much more than 2. So it's a 1-to-2 ratio. So then our final answer would be MN, we have one of them, 02. Okay. All right, let's try another practice problem. This time, really pause it, see if you can do it by yourself, and see how you do. All right, so this time we're going to determine the empirical formula of a compound composed of 25.9% nitrogen and 74.1% oxygen. Okay, so we'll start with the table, and I will put nitrogen, which is 25.9% or grams, and oxygen is 74.1. Molar mass of nitrogen is 14.01 grams, and oxygen is 16. Okay, so now if we try to figure out the number of moles, we're going to have nitrogen is going to be 25.9 grams divided by 14.01 grams bottom, mole on the top. And that gives us 1.85 moles. Do it again for oxygen. So we'll have 74.1 grams of oxygen, 16.00 grams of oxygen, 1 mole of oxygen. Cross out, multiply across the top and bottom and divide, and I came up with 4.63 moles of oxygen. All right, let me clean this up a little bit before I get onto the ratios. So remember, now we look and find the lowest ratio, the lowest mole, which in this case is the nitrogen. So we're going to divide both moles by the lowest, so 1.85 divided by 1.85 is 1, and 4.63 divided by 1.85 is 2.5. Okay, now this time, 2.5 is right in between 2 and 3. So we can't round up or down in this case. We're going to need to multiply. So I always start by multiplying with the smallest number, which is a 2, which may or may not work. So 2.5 times 2 is 5, and 1 times 2 is 2. So our empirical formula is now N2O5. Okay, so that's it for writing empirical formulas. It's really not that difficult. There's just a lot of steps. Okay, we now need to talk about molecular formulas. So the molecular formula is a whole number multiple of the empirical formula. Okay, and to calculate a molecular formula, you're going to use N times the empirical formula equals the molecular formula. Okay, N is always a whole number, and the way you get N is by this one right here. It's the molar mass of the compound divided by the molar mass of the empirical formula. Okay, so this is really, you figure out molecular formulas after you've figured out the empirical formula. Okay, and this is pretty basic. So let's try one. And I guess we need a practice problem. So let's say I have a compound whose empirical formula is CH4N. And the molar mass of the actual compound is 60.0 grams. Okay, so this is our practice problem. So the first thing you do is calculate the molar mass of the empirical formula. Okay, well, our empirical formula is CH4N. Okay, and to figure out the molar mass, we've been doing this. It's 1 carbon plus 4 hydrogens plus 1 nitrogen. You get those numbers off the periodic table. So let's calculate that and see what we come up with. And I calculated 30.06 grams. Okay, and that's the molar mass of the empirical formula. Okay, now we need to solve for N. To solve for N, we need to take the molar mass of the compound, which was already given to us right there, divided by the molar mass of the empirical formula, which we calculated here. So we're going to have N equals 60.0 grams, molar mass of the compound, divided by the molar mass of the empirical formula, which is 30.06 grams. And when you put that in your calculator and round, coming up with 3 sig figs, you end up with, well, I got 1.9, let's do it all the way, 9600 and so forth. Grams cancel out. Okay, so now we have our N. We're now going to round N to the nearest whole number, which would be 2. And then we're going to multiply the empirical formula by the value of N to get the molecular formula. So our empirical formula was CH4N. Okay, that was our empirical formula at the beginning of our problem. We're going to multiply this by our N, which is 2. All right, so we're going to end up with C2H8N2. And that's really all there is to a molecular formula. What you can see is that here's the empirical formula, and here's the molecular formula. And what you can see, hopefully, is that the molecular formula is a whole number ratio of the empirical formula. Okay, let's try a practice problem. If possible, try to do it by yourself. Then hit play and see how you do. All right, so far we know the empirical formula and we know the molar mass of the compound, which we'll need later. We use the empirical formula, P2O5, to figure out and get the molar mass of the empirical formula, which you get using the periodic table, and I came up with 141.94 grams. Okay, and then we solve for N. So N equals the molar mass of the compound, which in this case is 284 grams, divided by the molar mass of the empirical formula, which is 141.94 grams. And when we calculate that, N turns out to be 2.0008 and so forth. We round to the nearest whole number, so it's 2. We now take that 2, take our N, and multiply it by the empirical formula. Remember, it's N times empirical formula. And that gives us the molecular formula, right? So we're going to have 2 times P2O5. So P we end up with, gosh, I'm kind of out of room here. Let me erase a little bit. We end up with P times 2 is going to be 4, right? So we're going to end up with P4O10. All right, That's it for today. And guess what? That's it for the semester. No more lectures this semester. Have a good one.